Hello everyone. In this video, we will take an exercise on arrays and their usage to represent vector in mechanics. So please, I would recommend at this point is that you stop the video, read the question here, and attempt on your own to write a MATLAB script that solves this question. And at the end, you can watch the video and compare your calculations with ours. All right, so let's start. We are asked in this problem that we were told that there is an object that moves horizontally in the plus x direction a distance of 3 meters. So that's the distance that this object moves, and it's shown here with a red arrow or a red vector. The force F1 is known and is given by 10I minus 4J units of Newton. The force F2 is two-dimensional in the XY plane as well. So that I think is hinting to the problem being a two-dimensional problem, no 3D calculations. But the force F2 is not known a priori. We are asked to write a MATLAB script that reads an array from the user representing the force F2 and then it calculates few things. The first one is the net force as a vector. So let's actually stop here and try, to start on this part. Let's get a new script. Let's save it with some name. So I'm gonna save this. I will call this maybe vectors example .m. And I'm going to save it. So this is my vectors example problem. The first thing, it seems I need to take as an input from user F2. So I need to take the array F2 as an input from user. I'm going to write here a comment. So taking F2 from the user, and this happened using the input function. So I'm going to type F2 equals input, and then between parentheses, as we learned before, please enter F2 as an array. So this might be a little bit new because we are not used to combine the input function with arrays, but it turns out that they are very, very compatible. So to test this, let me actually, before doing any calculation, let me run this script. So it says, please enter F2 as an array. So I'm gonna enter an array that contains 2 elements. So maybe 4 and 5, and that's fine. So it seems that the input function in MATLAB accepts arrays as an input. No problem in that. All right, so I can keep going now. I'm going to put a semicolon here, and because I will be clearing and testing the example several times, maybe it's a good idea at the beginning to put clear for the screen and clear the variables in the memory, just so that my calculations in one trial do not overlap with the calculations in the previous trial. All right, so I managed to obtain F2. This is very, very good achievement, and the semicolon at the end here just to suppress rewriting it again on the screen. Now I want to calculate the net force. This is simple. This is very simple because the net force is simply, let's a little bit analyze this. The net force, I can call it F net. It is basically F1 plus F2 as vectors. So maybe first I need to type the vector F1 because this is actually known. I don't need to take it from the user. It's actually 10 negative 4. So this is F1, which is known. I want now to calculate F net. And you might think that you need to calculate F net element by element. So for example, you might think that you need to add F1 of 1, which is the first element in the array F1, to the first element here, which is F2 of 1, and that will be your first element in the array F net. Similarly, you want to do this with the second element. But it turns out, and we will demonstrate this now, and we will expand on it in a further video, that you can simply type fnet equals f1 plus f2, and this will do component-wise addition. And let me actually test this in the command window to demonstrate this idea for you. So let me clear here and clear. Suppose x is a vector that has two components, and suppose y is another vector that has another two components, let's say 9 and 5, and I want to add them in vector-wise addition, which is, adding each component to each other. The answer should be 1 plus 9, and that's 10, and then 4 plus 5, and that's 9. So simply if I type x plus y, that actually gives me a vector, which is the answer vector here, and it contains two components. So in fact, you can add vectors or add arrays with the symbol notation of the plus sign, which applies to scalars, right? So that actually is a big achievement. We managed now to calculate the net force. So we completed the first part. And then it says, calculate the magnitude of the net force in Newton and report it to the user. All right, so in fact, there is a built-in function in MATLAB that allows you to calculate magnitudes of vectors, but maybe it's actually a good idea to practice programming, right? Or practice arithmetic one more time. So remember, if there is a vector v that has component v1 in I direction and v2 in j direction, and if you want the magnitude of v, that's basically v1 square plus v2 square and then square root. So let's actually apply this here. I will say the magnitude of fnet, let me call fnet mag. That's actually the square root of the first component of fnet is fnet of 1. Remember, that's how you get the first component of an array, and this has to be squared. Plus the second component of the same array, it's fnet of 2. And again, this also have to be squared. So this is the square root of the first component square plus the second component square. All right, so that actually resolves the second part of, or the second part of this question, which is part B. I need to report it to the user, and I'm not concerned of this being a complex number, so I can actually use fprintf, or I can use disp. Both of them are fine. So let's actually try to use disp here. So disp, remember disp, I'm gonna report an array of strings here. So the first string is the magnitude of the net force is, and then let me leave space, and then semicolon, and then close the quotation mark, and then num to str of, I need to convert from a numerical to string the variable fnet underscore mag. All right, and then maybe I can put newtons. So and again, remember, I need to leave a space here, and I need to leave a space here just to look nice when it writes it on the screen. That actually completes the disp command to calculate, to represent this to the user. Now, part C of the question says it also calculates the angle between the net vector and the plus x-axis and reports this angle to the user. And herein we are asked you to learn a new function, trigonometric function in MATLAB, the atan2d in MATLAB, which reports the angle in degrees. So it's not going to be in radians. So it is in degrees, and it's between negative 180 and plus 180. So atan2 D, so the D means it's going to report it in degree, and 2 because it reports the answer between negative 180 and plus 180. The format of this function is this way: a tan 2dy comma x, where y and x are the components of the vectors. I think there is a missing part here of this question, are the components of the vector. So we need to report the angle theta that this vector or force net F net form with the x-axis. So let me just briefly remind you of how this works. So remember, so far we had two vectors, F1 and F2. If we go back here, F1 is actually pointing downward in this way. So this is F1. And F2 could be any other vector given by the user. So I don't know exactly where is F2. So maybe it's something like this. It depends on the user input. And then we calculated the net force using MATLAB. So this is, F net is something like this. So this is F net. And I want to report the angle theta between F net and the x-axis. So remember, this is the x-axis. So if this is the y component of F net, so let me call this F net y component, and this is the x component of F net, so let me call this F net x, then tan or theta equals tan minus 1 F net y divided by F net x. And that's pretty much what the a tan 2D function is doing. So let me do it here, computing theta with x-axis. So let me call it theta this way, maybe that's fine. So I'll call it a tan 2D. Function accepts two inputs. So if you go back to the problem, I need to type the y component first and then the x component. But the question is, what is the y component of the vector F net? It's the second component. So that's basically, it's F net of 2. So that's the y component. And the x component is F net of 1. So this exercise really emphasizes referring to elements inside the array. So I'm referring to the second element because physically that is the y component, and the first element because it's physically is the x component. And then what's asking me to do, I probably need to report this to the user as well. Let me actually use fprintf in this case. So fprintf, if you remember, there is something here I need to report in the format. So the angle with x-axis is, let me write this in degrees, is I will present it as a real number, so it's percentage sign f, and the variable I am reporting is theta. So remember, the percentage sign f will be replaced by theta. So this is also, good to remember fprintf and disp at the same time. Finally, it calculates the work and reports it to the user in units of joules. Well, here is work calculations. I want to remind you something from the theory of mechanics. Let's actually go to the next page. So let me remind you of some, or actually even a new page. We might need a new page here. So from the theory of mechanics, for a constant force, so you don't need to perform any integrations, the work is the dot product of the net force times the displacement. But we do actually have F net because we computed the net force using our script. What remains is to represent the displacement vector. And if you go back to this problem statement, it says that the object has been displaced along the positive axis by a distance of 3 meters. So it wasn't displaced in y direction. So because of this, this vector d is 3 in I direction, and there is nothing in, and it's actually basically 0 in j direction. So I can actually represent it as a two-dimensional array, and it is 3 and 0. So this is the displacement vector. And now I can calculate the work. Let me call it W. It is the dot product of the vector F net, comma, vector D. and I can report it to the user. Again, maybe I can use this for fprintf. Well, if the force is in Newton and now D is in meters, so according to SI units, the work has to be in joules. So I can say that maybe this time, so the work in joules is, I can leave a space here, and then, I'm sorry, I forgot the brackets for the array of strings, and then num to str of what's the value here? It's down. All right. So I think we are ready now to test this code. Let's so that completes the script we have been working on, and let's actually run it and see what are the outputs. So let me do TLC. I think we missed something, and that's in the printf. In fact, because it will not look nice, whatever fprintf is right will be, immediately written after it. Immediately we will get the result of the work, and to avoid this, I need the \n, which is like hitting enter on your keyboard to move to the next line. Now I can run. So let's run. Enter some array. Let me write any array, some force. So it's 1 in x direction and maybe 7 in y direction. And let's see the results that we obtained here. If we go up, so the magnitude of the net force is 11.4018 newtons. So that's the total net force. The angle with the x-axis in degrees is 15.25, and the work in joules is 33 newtons. I think let's actually confirm. It's usually good to validate your codes. So I have F1. It's given in the problem statement, and it is given here as 10, -4. I have F2, which is 1 and 7. If I calculate the vector F net, that's basically 11 here and 3 here. And let me try to at least validate the work. So it's basically F net, which is 11.3.30. And yes, according to the dot product definition, this is going to be 33, which is 11 times 3, plus 3 times 0, which is 0. So it's 33 joule as written here. So at least this validates part of the code. And it is recommended actually whenever you want to write a code to validate each piece of it. So ideally, we should, do some hand calculations for each part of this code to validate it. And we will leave this as an exercise for the viewer. Thank you so much, and see you in another video.